All right, guys, here we go. You guys have actually been working on this for longer than you guys have known. Everything we did last week, maybe it's not a surprise for you. When we're finding the instantaneous rate of change or when we're finding the tangent slope, that's actually a derivative. So there it is. This is what we were doing last week, right here. See, we defined the slope of a curve at a point where x equals a to b, and that's what we found. When it exists, this limit is called derivative of f at a. In this section, we investigate the derivative as a function derived from f by considering the limit at each point of the domain of f. All right, all that means is that we're going to be taking the derivative with respect to f, with respect to x. So see, we're not going to find it right at a point, but we can plug in any x value to get my tangent slope. So yeah, that's it, guys. That's all we're doing. So we're just doing. See, by the way, what do you call this? You call this f prime. This is how you say f prime. What's the derivative of a cow? Prime rib. You know, because prime. That's how you say prime. LOL. You could also say dy dx. This looks a lot like change in y over change in x, but remember, this is the average rate of change. It is an instantaneous rate of change. So they're related. This is called a differential, dy over dx. Sometimes they approach practically zero, sometimes they don't. So this is why, yeah, but okay, we'll get to that when we're more advanced. So example one, all it says is find the derivative of f of x equals 3x squared. Once you find the derivative, find all three of those. Okay, so find the derivative. So I'm just using this formula. I'm going to go f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. That's all I'm doing. I already have f of x. F of x is 3x squared. I need f of x plus h. I'm going to put parentheses. Well, first I got to put 3. 3 parentheses, wherever there's an x, I'm going to substitute x plus h. X plus h, close it, squared. So let's see, 3 parentheses, x times x. X times h. xh, but I'm going to have 2 of them. And then h times h. There you go. Distribute the 3. Hey, Rodriguez, where are you going? You can't just leave, miss. 3x squared plus 6xh plus 3h squared.
I have 2 passes. One, because I was late, because I was in a meeting with Cash, and the other is to go to dance.
Okay. I trust you, miss.
Oh, I thought you needed these.
No, I don't need them. Well, I don't need them. Because it's not like you're not going to go skip or something, right? Yeah, we're good. Okay, here. All right, guys, here we go. I'm just plugging it in now. Limit as h approaches 0. I'm plugging in this for f of x plus h. 3x squared plus 6xh plus 3h squared minus 3x squared. All this is over h. What's going to zero out first? The 3x squares. What can I factor out? On h, so here it is. Limit as h approaches 0. Here's my h factored out. 6x plus 3h, close it, all over h. Now it's going to cancel. Not everyone at the same time. H's cancel out, and now h is approaching 0. So what I have here is just 6x. So what's the derivative of 3x squared? 6x. I'm going to find all these 3 that they told me to find. F prime of 1, 6 times 1, 6. F prime of 2, 6 times 2, 12. F prime of 3, 6 times 3, 18. What do you guys think? Not bad, right? Say it again. Oh, instead of plugging in the number directly, f of 1, finding my slope at 1, finding my slope at 2, finding my slope at 3, I'm finding the expression for the derivative or for my instantaneous slope, and then just plugging in that value. I could have plugged in the 1, 2, and 3 immediately right here, and then found it like that, the 1, and then plug the 2 in to find the 2, and then plug the 3 in to find the 3. But now I just left it in terms of x, got an expression, and then just plugged in 1, 2, and 3 for x. Yeah, derivative is a tangent slope. Derivative at a specific x value is a tangent slope at that x value. It's the same. I wouldn't call it simpler. It's just the same. To find an instantaneous rate of change. Yes, so if you wanted to, but why would you if you want to find the derivative at several values, it's probably easier to get it in terms of x. You know what I mean? Yeah. I mean, you could, but I think it's probably easier just to do it in terms of x. Are we okay, guys? All right, here we go. Let's go to the next page. You already know this. Notice this is derivative at a point. This is what we've been doing lately, and this will get you that derivative right off the bat. So I'm going to use this to get, I'm just going to do the 2 and 3 because the 1, it's not, I don't think we need to do it 3 times. So here it is. I'm just using this formula. Find the derivative of example 1, this time using the alternate definition. Okay, f prime of 2. So remember, at 2, I better get 12, and at 3, I better get 18. So f prime of 2 equals, so what do I need? I need f of 2. F of 2 equals 3x squared. So yeah, 3 times 2 squared. 2 squared is 4. 4 times 3 is 12. All right, so here we go. Limit as x approaches 2. And this is f of x. F of x was 3x squared minus f of 2. F of 2 is 12. All over x minus 2. I can't plug in direct substitution right now because I get a 0 in the denominator. So I have to do something with my numerator, my algebra. I'm going to factor out a 3. Limit as x approaches 2. Here's my 3 factored out. X squared minus 4. Close it over x minus 2. I still can't do direct substitution. So I'm going to do the difference of squares in the numerator. Limit, I still haven't evaluated it yet, guys. Limit as x approaches 2, 3 parentheses, x plus 2, x minus 2, all over x minus 2. OMG, now I have a common factor I can cancel. What am I going to cancel, guys? Bam. Now can I do direct substitution? Yes. 2 plus 2 is 4. 4 times 3 is 12. OMG, look at that. F prime of 2 is 12. Is that what I got earlier? Yeah. Let me do the 3 one now. So here it is. I'm going to do it in blue. F prime of 3 equals limit as x approaches 3 of 3x squared minus, I got to do f of 3 over here. F of 3 equals 3 times 3 squared. 3 squared is 9. 9 times 3 is 27. 27 over x minus 3. Have I freaked anyone out? All right. I'm going to factor out a 3 in the numerator. Limit as x approaches 3. Here's my 3 factored out. X squared minus 9. Close over x minus 3. Again, I'm going to do the difference of squares with the x squared minus 9. Limit as x approaches 3. 3 parentheses x plus 3, x minus 3. All over x minus 3. What's going to cancel out? 3 plus 3 is 6. 6 times 3 is, and OMG, look at that. F prime of 3 is 18. Did we get the same answer that we got over here? Yeah. See? Remember, we've been doing this already a long time. These are just tangent slopes at those specific x values. Now, there's a special name. They're called derivatives. Cool or not cool? Ms. Kalia Kyle? Oh, the pretty long yawn there, Ms. Kyle. Bam. All right. Here are different ways to label or to call this derivative. Just like what I told you. Look at this. Y prime. What's the derivative of a cow? Prime rib. LOL. This dy dx, guys, dy dx, or the derivative of y with respect to x, df dx, or derivative of f with respect to x, and sometimes they put parentheses on this. So sometimes you can do something like, this is the same thing as saying d dx of f of x, like that. See? You're taking the derivative of whatever you have on the end side. By the way, guys, this dy dx, this is an instantaneous rate of change. They're related. If you're wondering, like, what is that? That is related to this. One is instantaneous rate of change. One is average rate of change. Which one is average rate of change? Yeah, no, average. The triangle one, the delta y over delta x. The instantaneous rate of change is the dy over dx. Are we cool, guys? This is also called the differential. We'll get there when we get there. Right now we're rookies. Okay, here it is. All we're doing, bless you squared, bless you cubed. Oh, okay. All we're doing right now is just, no more yawning. The next yawn is a demerit. I'm kidding. No, I'm not right now. All right. Sorry, I'm thinking about these little. Okay. It's okay, fine. Let's take a derivative, guys. Here we go. So all I know right now is this. F prime of x equals limit as h approaches 0, f of x plus h minus f of x all over h. That's all we know right now. Let me get closer to you guys. There we go. All right, here we go. I have f of x. I need f of x plus h. Square root x plus h. I got everything I need. F prime of x is equal to limit as h approaches 0. I don't need an f. Square root of x plus h minus square root of x all over h. Are we still okay? All right, I'm going to multiply by the conjugate because I'm trying to get an expression. So I'm going to go times square root of x plus h plus square root of x over square root of x plus h plus square root of x. Are we still okay? Okay. The top, we're just going to multiply. That's just like difference in squares, guys. Limit as h approaches 0. Square root of x times square root of x plus h and square root of x plus h is going to be x plus h. Square root of x times square root of x is just going to be x. All over h parenthesis square root of x plus h plus square root of x. Close it. Close and then close. Okay? All right, next. What's going to zero out in the numerator? The x's. Now, once I cancel those out, what else can I cancel out next? What is h approaching? H is approaching 0. So here's what I'm going to get. I no longer have to write the word limit. 1 over square root of x plus square root of x. So that's h is approaching 0. What's square root of x plus square root of x? What is it? What? Yeah, 2 square root of x. There's 2 of them. There it is. That's my derivative, guys. So what's my derivative? I'm going to go f prime of x equals 1 over 2 square root of x. That's my answer for that one. How do we feel? Let's go to the next one. All we're doing is finding the derivative. We're using our preferred formula. So what formula am I using? This one. Limit as h approaches 0, f of x plus h minus f of x all over h. This is how you find your derivatives. We're still okay? All right, here we go. F prime of x equals limit. Well, I guess what I need is f of x plus h. F of x plus h equals 1 over x plus h. Okay, now we're ready. Limit as h approaches 0. 1 over x plus h minus 1 over x all over h. Are we still okay? Common denominator, I'm going to multiply this one over here by x plus h over x plus h. I'm going to multiply this one here by x over x. When you do that, here's what I get. Limit as h approaches 0, x over x parenthesis x plus h minus x plus h over x parenthesis x plus h. All this is over h. I'm going to keep change flip. I'm going to keep this. I'm going to distribute the negative. See? Limit as h approaches 0, x minus h. Don't forget to distribute that negative over x parenthesis x plus h. Close it h. Does everyone know how I got that h there? I did keep change flip, guys. This is like h over 1, so times 1 over h, and that h is going to go to the denominator and the numerator, if that makes sense. Okay, Kyle? Yes. If I have a side note here, a over b over h, because that's what we're having issues with, right? If I make this like h over 1, keep the ab, change it to multiplying, 1 over h, look where it ends up. A over BH. So the h just slides down to the denominator of the numerator. Okay. That's a side note. All right, here we go. What zeroes out first in the numerator? Next, what can I cancel out? Notice I have a negative 1 in the top. Limit as h approaches 0 of negative 1 over x times x plus h. I guess I didn't have to go this far. All right, now h is approaching 0. So I have negative 1 over x times x, which is, yep. So here it is. F prime of x equals negative 1 over x squared. Do we see what we're doing, guys? We got it? Okay. All right, let's go to the next one. Yeah, I put f prime in there. Thought I heard someone say that. All right, here we go. All I'm doing is the rule again. I'm just doing f prime of x. So I'm writing my rules every time. Limit as h approaches 0. F of x plus h minus f of x all over h. So here we go. I need f of x plus h. So 5 parentheses x plus h, close it squared. 5 parentheses x times x times h, xh, but I'm going to have how many of those? 2xh, and then h times h. Distribute the 5, bam, bam, bam. 5x squared plus 10xh plus 5h squared. We're ready? I'm going to write f prime of x equals limit as h approaches 0. 5x squared plus 10xh plus 5h squared, that's your f of x plus h, minus 5x squared, that's your f of x, all over h. We're still okay? What's going to zero out first? Let's do blue. What can I factor out now? Limit as h approaches 0. Here's my h factored out. 10x plus 5h all over h. What's going to cancel next? No. I mean, you can, but then it's not going to, yeah. Because you'll have a, well, I mean, you can. You'll get the same answer. Because you have a 5 on the outside, and it's just going to be 5 times 2, which will get you 10 anyways. All right, here we go. H is approaching 0. 5 times 0 is 0, so I'm just going to get f prime of x, or the derivative, is 10x. Okay. All right. You can, if you want, do all that for this one, but do you have to? No. This rate of change is always constant. What's my rate of change of a linear line? Yeah, it's always, so you can just write f prime equals 7. That's your first, one of your first properties. Right, hold on, let me tell these guys too. Hey guys, can you guys lower your volume a little bit, please? No, we're good. All right. Go to the next page. Are these two questions in your notes? Okay. Do we have to worry about number 1? You don't have to do anything for number 1. For number 2, we're going to have to, though. So here we go. What do I need for this one? I need to know what f of x plus h is. X plus h, close it squared, minus 2. X plus h plus 3. From there, let's see. X times x, x squared. X times h, xh, we're going to have 2 of them. And then h times h. Minus 2x minus 2h plus 3. Nothing combines. I don't see anything that combines. So here we go. F prime of x, which equals limit as h approaches 0. I'm just doing this. My f of x plus h is this guy, so I'll just write x squared plus 2xh plus h squared minus 2x minus 2h plus 3 minus, open parenthesis, this is my f of x squared minus 2x plus 3, and all this is over h. Are we still okay? Next, what would I do next? I'm going to distribute this negative. So then, let's see, I'm going to move this. So then this would be minus. So I guess I could have just did, this will be a plus, and this will be a minus. Do you see what I did there, guys? All right, here we go. What zeroes out? The x, oh yeah, the x squares, the 2x's, and the 3's. Everything from the f of x should cancel out all the time, forever and ever. Always and always. Now I can factor out an h. You okay, Kyle? It looks like that's what I have right now. The h's are going to cancel out. And it looks like h is approaching 0. So I'm going to have 2x minus 2. So there it is. F prime of x is 2x minus 2. How are we doing, guys? Okay, let's go to the next one, number 3. I need f of x plus h. So wherever you have an x, you're going to replace it with x plus h. 1 over x plus h, close it squared. So let's see what that is. 1 over x squared plus 2xh plus h squared. Excuse me. Here we go. F prime of x equals limit as h approaches 0. F of x plus h, which is this guy right here, minus f of x, which is just 1 over x squared, all over h. We're still okay? I need to get a common denominator. So I'm going to multiply this guy here by x squared plus 2xh plus h squared over x squared plus 2xh plus h squared. I'm going to multiply the one on the left by x squared over x squared. So here's what I have. Limit as h approaches 0. So this looks like x squared over, and I'm not going to distribute this. I'm going to leave it like this. X squared parenthesis, x squared plus 2xh plus h squared minus x squared plus 2xh plus h squared, bless you, over x squared parenthesis x squared plus 2xh plus h squared. All this is over h. I was going to skip a step, but I decided not to. I want to show everything. I think I have enough room to write it here. Let's see. Don't forget to distribute this negative. Limit as h approaches 0. X squared minus 2xh minus h squared. Yeah. All over x squared parenthesis x squared plus 2xh plus h squared. Close it. Bring the h up. The x squares 0 out. Bam. I can factor out an h. So here's what I have. F prime of x equals limit as h approaches 0. Factor out an h. Negative 2x minus h all over that again. The h's cancel out. And now I can do direct substitution. This h is approaching 0. That h is approaching 0. That h is approaching 0. So you have negative 2x over x squared times x squared. So negative 2x over x to the 4th. We're almost done. What can I cancel out? One of the x's. Negative 2 over x cubed. So my derivative, or my f prime, negative 2 over x cubed. How are we feeling, guys? Yeah, look at your paper. Is it filled with really cool awesomeness? All right. This next questions, delete them. They're just from your homework. The only difference is this time I put a prime in there. They're from your homework. They're the same questions. We're going to skip them. Is that okay with you guys? Here's how your UH is going to look. All you're doing is using this. It says, given f of x, which of the following expressions represents f prime? Remember how f prime of x is? Limit as h approaches 0, f of x plus h minus f of x all over h. Can it be letter A? Remember, for f of x plus h, you're plugging in x plus h for all the x's. Can it be letter A? Nope, letter A is out. What about letter B? It doesn't have what in the front. Yeah, on yours is number 8. On yours is number 8 because I deleted the other two. On yours is number 8. On mine is number 6. It can be letter B because letter B is not even a limit. They might have tricked you guys because they do substitute incorrectly the x plus h. This is f of x plus h right here. And this is f of x all over h, but there's no limit in the front. No limit. So letter B's out. What about letter C? No, because this one is not approaching 0. This one, h is approaching x. See, they tricked you if you circled C. What about letter D? Is that the one? Yes, that's the one. I don't know. Maybe you had to be like, okay, hold on. What's my f of x? Maybe if you feel like doing this like this and then going, okay, f of x plus h, negative x plus h closed squared plus x plus h. Just don't expand it so UH doesn't look like they're expanding it. So f prime of x equals limit as h approaches 0, this expression, x plus h closed squared plus x plus h minus f of x. So f of x is negative x squared plus x all over h. Oh, look, that looks like that one. There it is. Do you see how we did it? What? What? Because it doesn't have x plus h. For substitute applications in each one. You know what I mean? No. Pascal, you doing okay? All right, guys, try the next one. See if you guys can do the next one on your own. On yours, it's going to be number 9. Is it letter A? Is it letter B? Is it letter C? No, that's the worst one. That's not even a limit. There's no word limit in the front. Is it letter D? Is it letter E? Yeah. It's letter E. Are we getting it, guys? Okay, go to the next one. Now you're going backwards. They give you the limit expression, and they want to figure out what is the equation, the original. Trav, what does this C? Relax, guys. Some formulas say the textbooks. Some textbooks use the letter A. Where are you? Over here. Some textbooks use the letter A. The University of Houston apparently likes the letter C. It does not matter, guys. So what they did is this. And I guess maybe I'm giving you the answer by doing this. F prime of C equals limit as h approaches 0, f of C plus h minus f of C all over h. So what do they want? They want to know what is f of x, question mark, and what is C, which is just some x value. All right, so give it a shot, guys. We'll give you the answer in a little bit, but give it a shot. No, because there's stuff on this. I would never stop.
What class is this?
Calculus, miss.
It's what?
Calculus.
It's what?
Calculus. Here.
Calculus. No, I'm good.
Take it and give it to me.
No.
No?
No.
All right. What answer did you get? Yeah, you're right. Did you say this one right here? Yeah, that's the answer. That's the answer, guys. If I were to tell you that my value is negative 3 and the function is x squared, you would go like this. You would say f prime of negative 3 equals. So let me go here to the side. F of negative 3, if it's x squared, that's going to be negative 3 squared, which is 9. And then f of negative 3 plus h is just going to be, I'm not going to simplify it. I'm just going to write negative 3 plus h close it squared. So check it out. If I do my limit as h approaches 0, negative 3 plus h close it squared minus 9 all over h. Yep, that looks like this. So yeah, there it is. You got it. I would let this, you see, right, guys, can you hear me? Because I'm a little sick, so maybe I can't hear. You see this right here? I guess this is also giving you a hint. That square there, immediately you're thinking, oh, negative 3 squared, that gives me that 9. And then you're looking at this guy like, oh, okay, well, I guess the function, my value must be negative 3, and the function must be x squared because, you're doing some expression squared. You know what I mean? Like your argument? Okay. Your argument. All right, you need a little bit of pre-count. Not much, but a little bit. See if you guys can figure out this next one, which in yours is number 11. You already got it? You ready for your unit circle? What do you think the answer is, Kyle? So here's a hint. You see this right here? This is obviously has to be f of c plus h, where c looks like. See? So then you think, okay, well, how do I get the square root of 3 over 2? Well, that has to be f of c. So what is f of pi over 3? Well, sine of pi over 3 is square root of 3 over 2. So then that means your f of x must be sine x. Because sine of pi over 3 is square root of 3 over 2. You guys see that? So if I were to tell you this, so in case you're wondering, Chava, I don't see it. What if I told you this? F of x is sine x, and I want you to find my derivative at pi over 3. You would say, oh, okay, f prime of pi over 3 is equal to limit, as h approaches 0, of sine of pi over 3 plus h minus sine of pi over 3. We'll figure that out right now. All over h. Oh, I took pre-calc. Sine of pi over 3 is square root of 3 over 2. Look at that. Limit as h approaches 0. Sine pi over 3 plus h minus square root of 3 over 2 all over h. Oh, look. That's what we have over here. So what was my function? Sine x at what value? Pi over 3. Yeah, those are a little tougher, but they can be done. You just got to slow down. Number 10, letter A. Find the equation of the tangent line at x equals 2. What are the two things I need for a tangent line? Say it loud. Yeah. Slope and point or point and slope. So, do I have a point? This is a point, guys. That's a point. The point is 2, 3. Do I have a slope? This is your slope. Slope at 2. Your tangent slope. That's your tangent slope at x equals 2, guys. So there it is. So here it is. Y minus 3 equals tangent slope 5, parenthesis, x minus 2. There's my tangent line. I did my formula, guys. Y minus y1 equals slope x minus x1. Are we okay? All right. Find the equation of the normal line. Well, the normal line is just perpendicular to your tangent line. So you're just going to do opposite reciprocal. That's it, of your slope. y minus 3 equals negative 1/5 x minus 2. There it is, guys. How do we feel? We're almost done, guys. We're almost done. Last page. So turn the page. All right. The graph of the function f of x is shown below, is made up of line segments joined end to end. Okay. At what x values between negative 4 and 6 is the function not differentiable? Guys, that means not differentiable means you don't have a tangent line. So what points can I not have a tangent line? Think about it, guys. I'm looking at these corners. Chop, why are you looking at those corners? My derivative to the left of that point is just whatever the slope of this is. My slope, let's see, up 2, right 4. So this is a half. My derivative is half, to the left of 0. And then if I approach 0 from the right, my derivative is, let's see, up 4, left 1. Negative 4. Do you guys see that? So if I have a slope of half at approaching 0, the slope of negative 4, right at 0, I don't have a tangent line. How am I going to look? Are you going to look like that? Are you going to look like that? You guys see what I mean? So you don't have a tangent line at x equals 0, so you're not differentiable there. Not differentiable at x equals 0, 1, and 4. Why, Chav? Why? Look, right at 0, guys, what's my tangent line going to look like? Bam. Bam. I don't know. How's it going to look? Choose one. You can't. You don't have a tangent line out at a corner, at that corner. You don't have a tangent line at x equals 1. How's it going to look? Like this? Like that? You don't have a tangent line at 4. Like that? Like that? So you're not differentiable at corners, like that. At cusps are like corners. Like corners. And obviously if you're not continuous. If you're not continuous, you can't have a tangent. Does that make sense, guys? Graph the function's derivative. All that means is to graph their slopes. That's all it means. Here's my grid. I hear some music. Do you watch the same show? Yeah, don't put it away, miss, please. You can have your laptop out, but not your phone. Okay. All right. Graph the function's derivative. So look, there's my derivative. Are we okay? All I'm doing is graphing my slope. That slope is a half between negative 4 and 0. Here's negative 4, here's 0. And I'm gonna say here's a half. Just a linear line at the half. I'm gonna say here's 1. Here is negative 4. This slope right here is negative 4. Open circle. Open circle. Between 1 and 4, what's that slope? It's a horizontal line, so the slope is what? 0. So between 1 and 4, my slope is 0. And between 4 and 6, let's see, I go up 4 and move 2 to the right, so 2. So I'm going to say here's 2. And between 4 and 6, here is my slope. All I did was just graph horizontal lines, guys. Because those are my slopes. Those values. They're all solid. Except for that's open circle, open circle, open circle, open circle, open circle, open circle. That's an endpoint, that's an endpoint of the top. But they're all open circles because you're not differential what 4, 1, and 0. You don't have like how do you choose what slope it is? Is it half? Is it -4? So it has to be open. You know what I mean? Just at those values. 0, 1, and 4. Alright. Can we do one more? Our last one. Relax. This is it. Sketch the graph at 1F. Plot this point first. 0, -1. And these are my slopes. So here we go. Zero, -1. That's a point. Here's -1. That's not a vertical asymptote. I just put it in there to help me out. Is this point to the right or to the left of this dashed line? To the right. So that means, look at this, this is a piecewise. That means I'm going to have a slope of -2. So at this point, I'm going to be going downhill. So make sure you're going to go downhill from that dashed line all the way to the right track. So I'm going to go up 2 to the left 1. I'm going to be right on that blue line. 1, 2, 1 point. That point is -1, comma 1. There it is. That's my slope of 2. Or -2, sorry. There's my slope of -2. I'm going down here. You see what we did there? All right. To the left of that, my slope is 1. So I go down 1, left 1. Put a point. Chop. Why are you going down left? I better be going uphill left to right. Down 1 left. I know this is not ideal. We're in the cafeteria too. It's not ideal to be here in the cafeteria to do this, but we're good. And there it is, guys. Call this f. That's your function. That's how it is. How do we feel? Notice, I didn't give you any extra work. There's no handout. There's no Delta Math. Make an attempt. Well, we should have made it yesterday. Make an attempt to make things that you did today and do by Sunday. Can we do that, guys? All right, we're good.